Hi everyone, welcome back to another video. So a little while ago I made a video covering this exam here that I'm holding in my hand, and it's more of a test. It's an IQ test, and it was one of the ones from Mensa, New Zealand, saying that if you can do well on this, maybe you'll have a good shot at getting into Mensa, a high IQ society. That has turned out to be a pretty popular video, and people love challenging themselves on some of these problems. But every time I think about it, I sort of think about the idea of trying to test intelligence based on a set of right and wrong answers, which essentially this test is. It's saying that some of these patterns are more valid than others, and you need to find the same patterns that the person who wrote the answers also found. But I want to take a little look at this exam with the question in mind, can any answer be correct, and can you basically fit a pattern to any sequence of shapes or numbers? What would someone with a 300 IQ do if they were to approach one of these tests? Just to clarify, I do know that IQs of, say, over 140 would be considered a genius level, so saying IQ 300 I know is a bit of a joke, and this video is a bit of a joke. But at least maybe it can be a bit of insight into the idea of overfitting, or, fitting overly complicated patterns to the data, which, model every single data point and capture all of the noise and random data points as well, not just the general trend of the data, which can be, a genuine problem to have if you're working in, say, machine learning or something like that. Or just trying to predict anything. You actually lose your predictive powers if you start to overfit your data or model it too closely. Back before we knew that the Earth and planets orbited around the Sun, we had some models, such as the Ptolemy model, that Earth was at the center of the solar system. And some of these scientists came up with more and more intricate and complicated models to try and explain every single, data point they could find. They had to come up with elaborate, circles and loops that the planets were following, which would explain why they appeared to be moving back and forwards in the sky if they were orbiting the Earth. I think it got to a point where this model was just so complicated, trying to explain everything in the wrong way, that ultimately it was better just to adopt a new model that made more sense. This video is filmed on the 31st of July, which is Harry Potter's birthday, so these glasses are a reference to that, but also perhaps they will give me the necessary IQ points that I need to answer some of these. So here's the exam, and if you've seen my previous video, this will be familiar to you. Now let's just start with looking at the very first question here. Now, the first one is asking us to complete the next in the pattern or in the series. So we've got A, D, G, J. Now, the low IQ or average IQ way to answer this would be to say that there are 2 letters missing between each letter here, and the answer given in the answers is M. But I thoroughly disagree with that, seeing as we can do this a much better way. So what we could do is naturally assign each of our letters to their numeral in the alphabet. So A would give us 1, D would correspond to 4, G to 7, and J to 10. Our sequence is now 1, 4, 7, 10. If we can find the next number in this series, translate it back into a letter, we will have an answer. So what are we going to do to find the next number in this series? Well, I'm going to do the thing that I think would be natural, and that's to fit a polynomial to these numbers here. You can have polynomials of increasing degree to model basically any sequence you want. So I'm going to model this with a 4th degree polynomial, which is as follows. 301 over 24, x to the 4 minus 155. And there's my polynomial there. You can check my working if you wish to. If we plug in an x value of 1, we will get a y value of 1. If we plug in x is equal to 2, we will get 4. X is equal to 3, we will get 7. X is equal to 4, we'll get 10. And x is equal to 5, which is really what we're trying to generate here, our fifth number in the series, well, x is equal to 5 would give us a y value of 314. I quite like that because it's, an approximation of pi. Now, the only problem is translating it back to a letter. Well, there's not 314 letters in the alphabet. There are, however, 26 letters in the alphabet. So if we do 314 mod 26, we will get an answer of 2. Okay, I'm sure you know how mod works. It's basically the remainder if we were to divide it by 26. We've got a mod of 2, which would correspond to a letter B. And now that would be my final answer to the question. It does not agree with the answer given by the answers, but I think there is nothing wrong with the way I've got it, and it is perfectly valid. So, moving on. The next one that I'd like to try is number 15 up here. It's one of these visual ones. I've watched a few episodes of Rick and Morty before I filmed this video, so I should be fine with coming up with something. Now, for the sake of it, I will give you what the answer says are the correct answers here. So we're again finding the next one in the series. We've got 1, 2, 3. Answers say that number C is the correct answer for what comes next, and they say this is true because the dash oscillates between these diagonal spaces, so it would oscillate back to here, and the dot moves around clockwise, so it would meet the dash there. I mean, you could do that, or you could do my method. Now, there's a little bit of setup for my method, but essentially, when I look at a square like the one given, I imagine it in a point system where being in this spot here would give you 1 point, here would give you 2, 3, and 4 points. Now, let's have a look at the behavior of the dot in the first 3 elements. So, in the first one, it's in position 1. The dot has accumulated 1 point. In the second one, it moves across to spot 2. It's now got an additional 2 points. And in this third one, it's moved down to have an additional 3 points. 1, 2, 3. At the end of this, the dot is on a tally of 6 points. Now let's look at the behavior of the dash. Starts off in the 2, so it has 2. Then we can add to that 4. And then we can add to that another 2. Now, we've got a tally of points for both of them, but what are we going to do with that? Well, the only logical thing to do with that would be to think, okay, we've got, one more element in the series, and wouldn't it be great if with that one last iteration, we could make the points for both of the shapes equal? Now, there are a couple of ways that this could happen, actually, and I'll draw the 2 possible options for the 4th item in the series. So the dot and the dash, well, we've got 6 and we've got 8. Well, we could imagine that they could go on to both equal 9, where the dot could gain an additional 3, so it would have to be here, and the dash would gain an additional 1, so it would be here. I guess that would be one option where the tally would come to a total of 9. Our other option is to bring the tally both to a total of 10. So the dot would have to gain an additional 4, placing it here. The dash would have to gain an additional 2, placing it here. All right, so that gives us both a total of 10. If we look up to our possible answers to pick from, this option here does not appear as an option, but this option here does. So I would say that my better and more correct answer would be B. I say the phrase more correct, but of course I mean that they both could be correct depending on what you're looking for here. If you're looking for a IQ 300 play, maybe that's what I've shown you. But if you're looking for how to score well on this test, being marked by whoever is marking it, then you'll have to try and simplify your reasoning down to give an answer of C. I'll try out one last one on the last page. Okay, so number 30 is a little bit different from what we've done already. We are wanting to find out what shape would go in this box here. So there's obviously some pattern things are following, and to make it a little tricky, they've blocked out these two squares so we can't see what was going on there. But we can still work out the pattern fine enough. Now a quick glance at the answers do say that A is the expected answer for this, so let's see if we agree with them. Now, first of all, I want to find out what is happening between this first line and this second line. So I, just from looking at it, can see a sort of a pattern already. If we count the number of sides on the smaller shape and divide it by the number of sides on the larger shape, well, what we would get is that the cross has 12 sides, the box has 4 sides, that division would give us 3, but if we were to square 3, we would get 9, and if we were to times that by 10, we would get 90 degrees, because that is how much it rotates in terms of where it's flying off to between this line and this line. Here it flies out to the right. Here this little box appears to be flying down, downwards. So that's a difference of 90 degrees. If we do the same logic, I think we can find out what kind of rotation this box would undergo when it turns into a dot and what angle it would fly off at. So let's count the number of sides. Of the little shape, we have 4. So that would be 4 divided by, well, a circle has 1 side, so that would be 4 over 1, that would be 4. 4 squared would be 16, times 10 would give us 160 degrees. So if this one is starting from the downwards position, we want to rotate 160 degrees, well, that would be 90, and then we'd have 70 more. We would expect a triangle with a circle flying out at 160 degrees relative to the base. So I would expect that to be somewhere like there. Now, that doesn't quite perfectly match any of our answers. This one, it flies out to the bottom, to the top, to the right. Well, it's definitely none of those. So I would agree that A fits our pattern most precisely, although not exactly. And there you go, I've solved a few problems there, and I guess you can try out the rest of them for yourself if you haven't already from my last video. So don't take that too seriously, it was really just a bit of fun to see if we can fit a model to anything we want to and kind of force our way to any answer possible. I guess there's something to say for, trying to measure intelligence from one set of answers. Whether mine are more intelligent or less intelligent is up to the viewer to decide, but thank you for watching.